Hi, in this video, we want to find or determine Q if the electric field at this point P is 0. So the field point is this is labeled P. So the resultant electric field at this P is 0. So let E1, E2, and E3 be the electric field at a point P due to Q1, Q2, and Q. So to solve this, we shall be making use of Coulomb's law, and Coulomb's law of force states that the force between two charges is proportional to the product of the charges. Let's say this is the first charge, this is the second charge, and this is the distance between them. So it's saying that this force is proportional to the product of the charges and inversely proportional to the square of the distance between them. And electric field is defined as the ratio of this, so force per unit charge. Force per unit charge. So we'll now see that if we divide this with this, we now see that electric field is K half Q upon R square, where K is 1 over 4 pi epsilon 0. So you have this upon R square. So we shall be making use of this to solve this problem. Now, looking at this configuration, we can find the distance between P and Q2. We can denote it as RPQ2. We can denote this one as RPQ1. And from Pythagoras theory, this is angle 90 degrees. We can find out that RPQ2 square will be 2D square plus D square. And this is 5D square. So if we make RPQ, of course this is Q2, subject of the formula, we have square root of 5D square, which is same thing as 5D square to the power of half. So this is 5D square to the power of what? Half. So it implies by this configuration that this also will be 5D squared to the power of what? Half. So we shall be making use of this to solve this problem. So we are told that the electric field due to what? Q1, and electric field due to Q2, and electric field due to Q at this point equals 0. So we shall be making use of this now to solve this problem. If today is your first time of watching this video, do well to give it a like and subscribe for more updates like this. You can go to our playlist to check that video which might interest you. So since electric field is a vector quantity, let us give it a direction. So electric field due to Q1 will be, according to this, we have 1 over 4 pi epsilon 0. So of course this will be R square. Okay. So we have the charge there is Q1 upon the distance. The distance now will be this. Distance along this Q1 will be, shall denote it as RP Q1. Then we square it, and the unit vector in this direction will be RP Q1 hat. So to find this RPQ1, we have found it before. We found it as 5D squared to the power of what? Half. So how do we find the unit vector in this direction? So the unit vector in this direction is given. So to get the unit vector in this direction, P Q1, we use this formula. Okay, so and this RPQ is this. RPQ, we have it as 2D. The direction now is along the y-axis. Have J minus RQ1. This is RQ1Q is D, and the direction is what? I. Upon, then we have RPQ. RPQ is this 2D, okay, minus RQ1Q is D. So once we do this, we now have that this will be 2DJ minus DI upon the magnitude of this will be 2D square plus D square, and 2D square plus D square, this will now be finally we have it as 2DG, this J minus DI upon, this will give us square root of 5D square, and square root of 5D square, we can compress it to look like this. We can make it look like this. This is 2DJ minus DI upon 5D square all to the power of half. So you now see that this is now the same as this. So the modulus of this, okay, 2D minus D. Of course, if we decide to put the direction J and this is I, the modulus gives us this. So that's what we'll be writing here. So we have that EQ1 will now be 1 over 4 pi epsilon 0. We have Q1. Now the distance square, look at this. So we have something like this, 5D square to the power of half. If we are to square everything, of course, if we are to square everything, this what we go. So we have terms. So we have this now as 2DG minus DI upon, we have 5D square to the power of what? Half. So this we go, and we have that EQ1 will be 1 upon 4 pi epsilon 0. We have Q1 upon, this now will be 5D square times, we have 2DG minus DI upon 5D square to the power of what? Half. So this will be the expression for the electric field due to what? Q1. So going further, we have that EQ1 now will be 1 over 4 pi epsilon 0, have Q1, then times 2DG minus DI upon, this is to the power of 1. We add it to this power. We now have that this is 5D square all to the power of what? 3 upon 2. So we have gotten the electric field due to what? Q1, and we have it as 1 over 4 pi epsilon 0. We have Q1 2DG minus DI upon 5D square to the power of what? 3 upon 2. So we shall be making use of this to again find other values of EQ2 and what? EQ. So if this is your first time of watching this video, as I've said before, do well to give it a like and subscribe for more updates. So to find EQ2, which is this is EQ2. So we still make use of the formula following from this. I have 1 upon 4 pi epsilon 0. In this case now we have it as Q2 upon the distance here, we take it as RP, is RPQ2. We have to square it and we write the unit vector in this direction. We write the unit vector in this direction. So normally this RPQ is Q2 is just the modulus of this, modulus of 2D minus, of course we have another minus here due to this direction. This is negative x, so plus D, the modulus of this, which we've gotten from Pythagoras rule to be this. We got it to be what? 5D square to the power of what? Half. 5D square to the power of half. Or you can use this formula that this is square root of 2D square plus D square, as we found earlier. So we have that the RPQ Q2 now is 5D square to the power of what? Half, as we can see here. So RPQ2 square will just be 5D square. Okay, because if we raise it to the power of half, this will go. Okay, have it as this. Power of half, we square it. If we square it, this what goes. We have that RPQ square will now be 5D square. And to get this unit vector in this direction, we have, let's write it somewhere. This is RPQ2 square, which is this. We have it as 5D square. And to get this unit vector in this direction, we have it as, okay, the unit vector in this direction will be RPQ, this vector, minus RQ2Q, this vector, upon the modulus of the vector RPQ minus RQ2Q. So that will be the unit vector in this direction. So to resolve this now, it will be RPQ2, the unit vector in this direction is, this is 2DJ minus, okay, this is already minus because it is towards negative. Of course, we are taking this as positive x-axis, we are taking this as negative x-axis. So minus the I upon, so this is 2D, of course this will be minus D. So this will be how it will be looking like. So we now have that finally the unit vector in this direction will be, this is 2DG plus DI upon, this will be square root of 5D square. So this can be written as 2DG plus DI upon 5D square to the power of what? Half. So the unit vector in this direction, let us write it somewhere. RPQ P Q2, we have it as 2dg plus di upon 5d squared to the power of what? Half. So we shall be employing it in this formula we have to find the electric field due to what? E2. So we have that. E Q2 will be 1 over 4 pi epsilon 0. We have Q2 R P Q2 square, got it to be 5d square, times the unit vector in this direction, we got it to be 2dg plus di upon 5d square to the power of half. So from the if we multiply this, law of indices, if we multiply this, we have that E Q2 will be 1 over 4 pi epsilon 0. We have Q2, this will be 2dg, this is j, plus di upon, this will be 5d square, okay, to the power of what? 3 upon 2. So we have got the electric field due to Q2. We have it as EQ2. This is EQ2. EQ2. We have got it to be what? 1 over 4 pi epsilon 0. We have Q2. Then we have 2dj plus di upon 5d square to the power of what? 3 upon 2. So what we need to find again now is the electric field due to Q. So to get electric field to Q, we utilize this formula. So this is 1 upon 4 pi epsilon 0 Q upon, the distance from here to here is this. So we have it as 2d square. The unit vector in this direction, following from our previous example, is this. Okay, this is 2d. We don't have any vector pertaining to this along the x, so we have it as this. So finally, we have the electric field contribution due to Q as this. So once we sum the contributions of the electric field, we now have that. If we sum it, the electric field due to Q2 plus electric field due to Q1 plus electric field due to Q at this point should equal 0. So we shall be making use of this to determine what? Q. So once we sum the electric fields, we have something like this. So we have, this is the electric field due to Q2, we have it as this. This is the electric field due to Q1, we have it as this. And this is the electric field due to Q. So once we sum this up, we now have that. Let's clean this. We now have that this will be, of course, this and this are same. This and this are same. And we made use of Q because we are told that Q1 and Q2 are equal. So they have that 1 upon 4 pi epsilon 0 Q upon 5d square to the power of 3 upon 2. Then we have 2dg, this is j, minus di, plus this, plus 2dj plus di. Then, of course, this should equal 0 by what we have here. So this again will cross. If it crosses, we have minus 1 upon 4 pi epsilon 0. We have 2q dj upon 4d square to the power of what's 3 upon 2. So let's clean here. So let's clean here. So this now will be, so we have 1 upon 4 pi epsilon 0. We have q upon 5d square to the power of 3 upon 2. This will cancel this. This will cancel this, so that we have this to be what? 4dj equals minus 1 upon 4 pi epsilon 0. We have 2qdj upon 4d square to the power of what? 3 upon 2. So this can cancel this, so that I have that q, okay, we can have 4qdj upon 5d square to the power, this is 5, to the power of 3 upon 2 equals minus 2q dj upon 4d square to the power of 3 upon 2. So this can cancel this. This can cancel this. Okay. So that will be left with, this will be 2 q. Okay, this can also cancel this. So that will be left with 2q upon 5d square to the power of 3 upon 2 equals, this is minus q upon 4d square to the power of what? 3 upon 2. So if we make q subject of the formula, we have that q equals minus, then we have 4d squared to the power of 3 upon 2 times 2q upon 5d squared to the power of what? 3 upon 2. Of course, we know that the value of d is 0.5, and the value of q, we are told that q1 equals q2 is 8 times 10 raised to the power what? Minus 6. This is 8 microcoulomb. So we have that this will be minus, this will be 4 times, okay, 4 times 0.5 square, all to the power of 3 upon 2 times 2q, 2 times 10 raised to the power, 2 times 8 times 10 raised to the power minus 6 upon, this is 5 times 0.5 to the power of 2, all to the power of what? 3 upon 2. So if we resolve this mass, we have that. So this will give you minus 11 times 10 raised to the power minus 6. So of course this is coulomb, and we can now have minus 11 microcoulomb. So the value of this charge, Q, is minus 11 microcoulomb. So if you have enjoyed this video, do well to give it a like, subscribe for more updates. Thank you and have a wonderful day.